For part A, for part 1, if you want the spacing between the constructive interference fringes to get bigger, then it would make sense to increase the distance L. So for part 2, it asks which wavelength of light will have its first maximum be located further from the central maximum, red light or blue light? The answer is red light because of its a longer wavelength. So because of it's a longer wavelength, the first maximum will be located further from the central maximum.
For the third part of part A, it asks if you want to increase the distance between the central maximum and the first maximum, should you increase, decrease, or keep d constant? So right here, this is what we're looking at, this distance here. And we said that you should decrease it because if you have the equation path length equals d sine theta, if you want path length to stay the same and you're going to increase theta, you need to decrease d in order to keep it proportional.
So in problem B, we're trying to find the distance between the center maximum and the third minimum. We want to use this equation down here, so we have to make sure that this statement is true. We plug in the givens for the wavelength and the distance between the two slits, and we get 0.1. 0.1 we found to be a lot less than 1, so this statement is true. We then plugged the givens into this equation down here, with m being 5 over 2. 1 over 2 is the location of the first minimum, 3 over 2 is the location of the second minimum, thus 5 over 2 is the location of the third minimum. When you multiply all of these numbers out, you get approximately 0.375. The given answer was 0.378.